The only difference here is whenever we talk about a histogram, all a histogram is a bar graph. Okay? A bar graph deals with categories. A histogram deals with like ranges of numbers. So like if we talk about like for the guys that play baseball, all right, you have different people in different like you have categories as far as the number of like singles you hit, doubles you hit, triples, home runs, so on and so forth, okay? Then, but whenever we talk about like a histogram, it would be like data values that are intervals, so like people that hit between like 200 and 250. How many people are hitting between 251 and 300? Does that make sense? Where there's multiple, it's not a specific category of like types of things that happen, but it's an interval of numbers. Does that make sense? Or even like with track or stuff like that. Or even like with, we could even do it like in terms of wrestling, like we have 106 to, or like if they're basically below 106, they would be in that weight class. If they're 107 to 113, they're in that weight class. It's just an interval of values. Now, the only thing different, whereas like wrestling doesn't count or wouldn't work, is that your intervals are all the same. So like whenever we talk about baseball, if we talk in like 50-point averages, you know, like if we go from 200 to 250, 251 to 300, so on and so forth, those intervals need to be the same. Okay? It still fits the same idea as far as what we've talked about yesterday with box and whisker as far as how it can be skewed. Symmetric, it's going to look like what's called a bell curve. Okay? If you think about what like a bell looks like, it's going to arc at the top and then it's going to fall off to the side. Okay? Whereas like if it's skewed left, you've got more of the tail on the left side, where if it's skewed right, the tail is going to be on the left, or on the right, excuse me. So, right, symmetrical, there is no tail. So from there, then whenever we describe the shape of the data, so whenever we draw, if this, in this case, it talks about number of tickets sold is between 1 to 8, 9 to 16, everything goes up in the same interval. So whenever we actually draw the histogram, so what this is over to the right is what's called the frequency table. It's basically just tells you how many times something happens in that particular interval. So whenever we do this, we have 1, 2, 3, 4, 5, 6, 7. So I would want to give myself basically 7 spots that are even. So there's 3, 4, 5, 6, 7. I'm going to put my intervals kind of going to the side. So 1 to 8, 9 to 16, 17 to 24, 25 to 32, 33 to 40. Did not do a very good job. Then 41 to 48. And 49 to 56. So from there, so my intervals are going to, oh, that's why. Don't zoom in too early so you can actually fit it in there. My fault. So 9. And then 49 to 56. So if here are my intervals, now what's the highest frequency that I have? What's the highest frequency that I have over here? 25. So what would you, since it's pretty short on the left side, what would you count by? 5? It's probably not a bad number. So if I go 5, 10, 15, 20, 25. So from there, all I'm going to do is make a bar graph, okay, with each interval. So I need to figure out, so 1 to 8 is 5, so all I'm going to do is just here, color it in. Do the same thing. So from 9 to 16, it is 9, so I'm going to go basically a little bit above 10. And whenever I do this, run your values basically all the way across, so that way you can just use the previous bar, okay, for your next interval. So if it's at 16, from 17 to 24, I'm going to go a little bit above 15, maybe a little bit too far. Run it over, shade it in here. Do the same thing from 25 to 32. Now this one's going all the way to the top. Shade it in. Okay, it doesn't have to be perfect. Okay. But for those of you that like to draw anyway, you might as well. At least draw something that's going to get you a math grade instead of just a picture. So 33 to 40 goes to 20. So go over to the 20, draw my line, drop it down. Do the same thing. 41 to 48 goes to 8, so that's about where 8 is. And then same thing for 7, so it's going to be a little bit below here and there. So here's my histogram. What would you say as far as, like, if I would actually draw a curve to it, okay? If I would actually put a curve on my histogram, would you say that it is symmetric? Is it skewed left? Is it skewed right? What do you think as far as your values and as far as your shape of your curve? Probably pretty symmetric, okay? It's never going to be exactly perfect, but for the most part, it's pretty symmetrical, because if I would, draw a line straight down here, it's pretty split left and right, okay? It's pretty split. There's not a whole lot that really is skewed one way or the other. Okay? It's when you have, like, your high point is pushed over one side or the other that it's going to be skewed the other way. Okay? That's where it's opposite. So if it's like your high point is on the left side, it's going to be skewed right. If your high point's on the right, it's going to be skewed left. Okay? Whenever we want to choose the appropriate measures, we've talked about before, or I've talked about, like, whenever I look at test grades and things like that, whenever the mean and the median are about the same, that's going to be pretty perfect. Okay? Whenever the mean is right in the middle and everything else as far as the median is probably going to be right there, it's going to be pretty symmetric. It's going to look a lot like our top one here that we have. It's when it's skewed one way or the other that the median will normally follow the taller side of the graph. So if you notice on both of these, the median's on the right where the high point of the curve is on the right. Same way, the high point of the curve is on the left, the median's on the left. Okay? And then the mean is always going to be in the middle. Okay, it's just a matter of where's the rest of the graph at in accordance to the data. Okay, so the mean is always in the middle, but it's a matter of how it's shaped that the median will get pushed one way or the other. Okay, I may have tests that average 75%, but the median score is like an 85. Okay, so what that tells me, as far as if I'm looking at the data and looking at those values, that means that I had over half of the class that got an 85 or above, which is pretty good. But what pulled it back, what pulled my average to the left or to the wrong direction? Probably some outliers, or people that, there may be a couple, maybe not just one, but there may be a few people that didn't do anything and got a 45% that pulled it really hard one way. Does that make sense? So whenever we want to choose appropriate measures, so this talks about a police officer measures a speed in miles per hour of 30 motorists. It says the results are shown in the table to the right. So what you want to do, so if it talks about the display of the data in the histogram using 6 intervals beginning with 31 to 40 to 35, basically what that means is if they're going to give you a starting value, okay, so if they tell you that we want to go 31 to 35. Okay, whenever we deal with my intervals, what's the next number after 35? 36. So this is going to be 36. So from 31 to 35 is how much? 4, but really counting the 31, it's really 5, right? Does that make sense? Okay, because we're even though 35 minus 31 is 4, we're still counting the actual 31 mile per hour. Okay, so there's actually 5. So like that one's going to go to 40. So 36 to 40. The next one would be then 41 to 45. What do you notice about this number and that number? They're 10 apart, right? Same way with the 35 and the 45. Okay? So this one would go then from 46 to 50. Do I need to keep adding values? Like, do I still have numbers over here in my table that are above 50? Yeah. So I would go 51 to 55. Do I need to keep going? Yep. 56 to 60. Do I need to keep going? Do I still have numbers do I have values that are above 60? No, so I can stop, right? Does that make sense? So from there, once I'm done as far as my table is concerned, then it just becomes how many values are between what I have, or in that, like how many values do I have 31 to 35? Well, 1. Any more? Go down. 31 to 35. Do I have any more than just the 32? Nope, so that's 1. What about... Yeah, you're good. What about 36 to 40? 1. 2. Where's the other one? Oh, there we go. So 3. Okay, so since 40 was on there, 40 is still in that interval, so we still have to count it. Then 41 to 45. So 45, 42, 41, 45 again. So 4. How many in the 46 to 50 range? 1, 2, 3, 4, 5. 5? 6? 6? Yes? No? Maybe? Those are gone. So then 51 to 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, did we miss any before? Did I miss a 49? So shouldn't that be a 7? Yeah? Sure, Laws. There we go.
41 to 45 should be 5. Because you missed something.
Did I?
Yes, you put it in there.
Oh, I did. That's why I've got multiple people looking. I just need multiple people to say something. So that should be a 5?
Yeah.
There we go. And then 56 to 60. 1, 2, 3, 4. Yeah. So just looking at it before I even graph it, what do you think? How do you think the data is going to be skewed? Does it all fit on? Does it look like it's going to be pretty symmetrical? Why not? 11's more towards the right or the bottom of my numbers, right? Okay. Same way with the 7, like the 11. So it's probably going to look. So it says the speed limit's 45 miles an hour. How would you interpret these results? So what would you, if it's 45, we have almost 22 people that go above the speed limit, right? Okay. 22 people fit in this category or above the speed limit. How many actually drive the speed limit or below? 9. So if you think about it, there are only 9 people that aren't getting a ticket. Okay, because they can give you a ticket if you go over the speed limit, right? If you're at it or under, you're good. Now, realistically, are they going to give you a ticket for going 1 over? Not unless you have a person that's not a very nice police officer and they want to ticket you. Okay? But they still can pull you over. Okay? So with that, since that end down here, basically it's going to look probably something, it's going to look something like this. Okay? As far as how my curve would look. So it would actually be skewed left. Okay? Because it's really getting pulled on that left side. Okay, whatever my mean or my median of my values would be, my mean and my median are probably going to figure out to be somewhere in this region. Especially my median. Okay, it's probably in that 46 to 50 range. Okay, to be perfectly honest with you. Okay.